Starting with this theory and analysis of composite material, as per the information given by the Punyashloka Ahilyadevi Hogar, Solapur University, Solapur for the syllabus for M.Tech Mechanical Design Engineering with effect from 2018-19 and this elective subject. For this, as a part of section first, initially we have completed the introduction to composite materials. Inside that we completed definition, classification, types of matrix materials and reinforcement, characteristics and selection, fiber composite, laminated composite, metal MMC, PMC, prepegs, application of composite, etc. This part we have completed. Then as a part of macro mechanical behavior of lamina, we started with the Hooke's law for different types of material, number of elastic constants, derivation of 9 independent constants for orthotropic material, two-dimensional relationship of compliance and stiffness matrix, stress-strain relations for plane stresses in orthotropic materials, strength of orthotropic lamina and numerical problems. So inside which now few numerical problems we are going to see, because this part we have studied already, and then we will go for the micro mechanical behavior. Is it okay? So for taking with this last discussion, because we have seen that whenever we are considering the material as anisotropic and homogeneous, is it okay? Anisotropic and homogeneous, in that case, we required 21 independent elastic constants. Whenever material is monoclinic, we required 13 independent elastic constants. Whenever material is orthotropic, we required 9 independent elastic constants. Then when the material is transversely isotropic, we required 5 independent elastic constants. And for isotropic material, the 2 independent elastic constants are sufficient. Is it okay? Now see here, the reduction of anisotropic material stress strain equation to monoclinic material stress strain equation, so that we have seen. Is it okay? Because the total structure and the total relationship of stress to strain, which is given by this particular equation, where total number of constants may be 36, but that 36 constants may get converted into 21 if we consider the heterogeneity as a homogeneity. Is it okay? If the material is considered as a homogeneous, then in that case, some of the constants, suppose this 1 4 is equal to 4 1, 1 5 equal to 5 1, like this gets converted here. Is it okay? So the homogeneity is the parameter due to which anisotropic material we can consider as a 21, monoclinic 13, orthotropic 9, transversely isotropic 5, and isotropic as a 2 independent elastic constants requirement. Is it okay? Now here, if we check identifying this stresses value, is it okay? So here, if we consider the stress values, is it okay? There is a plane of symmetry normal to directions. So we have seen at the time of the concept case when we are observing orthotropic material, etc. At that time, how this sigma 1 is get calculated, that we have seen. So in monoclinic material like this, 13 constants we are considering, because in that case this 2 4 becomes equal to 2 5, 3 4 becomes equal to 3 5, like this 4 with 4 6 becomes equal to 5 6. Is it okay? Now let us start with numerical part of this. So for this, let us have one example. The stress strain relation is given in terms of compliance matrix for an orthotropic material in equation 2.26 and equation 2.39. Rewrite the compliance matrix equation in terms of 9 engineering constants. Is it okay? So see here, A, B, C, D, E, like this different means. For A, it is considered a sigma 1. for B sigma 2, then for C sigma 3. Likewise for D, so this shear stress tau 2 3, how these two planes, plane number 2 and plane number 3 are taken into consideration in order to represent tau 2 3. Then for E tau 3 1, and then for F tau 1 2. Like this, the three stresses and three shear stresses that you can observe here. Is it okay? Now the question is clearly given here that stress strain relation is given in terms of compliance matrix for orthotropic material. Rewrite the compliance metric equation in terms of 9 engineering constants. Is it okay? So basically in this particular syllabus, one point is given here that stress strain relations for plane stress in orthotropic material. At the same time, there is one point here, that derivation of 9 independent constants for orthotropic material. We will consider this part as one kind of derivation of 9 independent constants in case of orthotropic material. Is it okay? Now let us consider here the compliance matrix for engineering constants for orthotropic material is already we have seen. Now stress and strain, in that if we write the equation in terms of strain to stress, then here it is observed that epsilon 1 is equal to S11 sigma 1, epsilon 2 is equal to S12 sigma 1, epsilon 3 is equal to S13 sigma 1. Similarly, three shear stresses are equal to 0. The Young's modulus in the direction 1, E1 is defined as E1 is equal to sigma 1 upon epsilon 1, which is equal to 1 upon S11. The Poisson's ratio gamma 12 is defined as gamma 12 is equal to minus epsilon 2 upon epsilon 1, which is equal to minus S12 upon S11. Is it okay? In the same way, if we write gamma 1 3, is it okay? So Poisson's ratio is lateral strain to the longitudinal strain. So with that reference, we are trying to write this equation. Is it okay? So already the relationship between stress and strain, which is given here in this way. Is it okay? So epsilon 1 in terms of sigma 1. Is it okay? Now, just you should think on this particular problem, and you should get the judgment to try to write the matrix. So try to understand this particular part which is in front of your slide. Each and every stress and strain, you just try to understand with this slide. I am giving you 5 minutes to understand this particular. Then you just tell me the value of each and every element. Yes, one, yes, one, two, how it is. Just I want to understand from you, because we have already studied this. Is it okay? So I am giving you 5 minutes to think on that.
Hello.